Today we will discuss another experiment, which is the shape test of aggregate. The shape test of aggregate is a laboratory test used to determine the shape and angularity of aggregate particles. It's an important test in civil engineering as it has a great importance in determining, or it can affect the workability, stability and durability of the aggregates. The main title is an experiment to determine the percentages of flaky and or elongated particles in aggregates. Now there is a need to tell you that what is the flakiness or the elongation. Flakiness refers to the percentage of aggregate particles that have a flat or elongated shape with a thickness less than 0.6 times their nominal size. In other words, flaky particles are those that are flat, thin, plate-like. Whereas the elongated particles, or we can say the elongated aggregate, are referred to as the percentage of aggregate particles that have an elongated shape with a length greater than 1.8 times their nominal size. In other words, elongated particles are those that are long, narrow, needle-like. We can say here are the flaky particles. Here we have the elongated particles. These are the flat flaky particles, or we can say the flaky aggregates. Coming towards the apparatus, we have the flakiness gauge, which can be demonstrated or shown in this figure, and then we have the elongated gauge. One thing is that we have to test the aggregate particles, which are the elongated particles, in their maximum height, or we can say maximum length. Then we have to check their elongation in this apparatus. Coming towards the theoretical background, flat or elongated particles do not reorient easily, making compaction more difficult. Such particles also have a tendency to fracture during compaction along their weak, narrow dimension, changing aggregate gradation finer. Flaky and elongated particles tend to lower the workability of concrete mix, which may impair the long-term durability. The dimensional ratio at which an aggregate particle is considered too flat or too elongated can vary from the specification to specification. Typical ratios are 2:1, 3:1, 4:1 and 5:1. Super pave mix design specifies a ratio of 5:1 and test particles for flatness and elongation. Flakiness and elongation are important because controlling flakiness and elongation is crucial, because they can significantly impact the performance and durability of the construction. By limiting the amount of flaky and elongated particles in aggregate, engineers can improve the workability and stability, or it can enhance the strength and durability. It can also reduce the material waste and cost, and ensure the safer and more reliable structures. Here we have the NHS specification, National Highway Authority specifications for asphaltic base coarse plant mix and asphaltic concrete bearing course. Lay down that portion of aggregates retained on 9.5 mm, which is 3/8-inch sieve, shall not contain more than 10% by weight of flat or elongated particles. A ratio of maximum to minimum dimension is equal to 2.5:1. No mention in aggregate base and sub base course in NHA specifications. Here we have British standard, which is 812, specifies that the presence of flaky or elongated particles in excess of 10 to 15% of the weight of coarse aggregate is undesirable. The standard also defines the flaky particles, the elongated particles and their mean size. The flaky particles are the particles whose least dimension is less than 0.6 times their mean size. and the elongated particles are those particles whose greatest dimension is greater than 1.8 times their mean size, which we have discussed earlier. Mean size is the average of two consecutive sieve sizes. Coming towards the scope of the test, we have the particle mass or particle count, or both may be used for test depending upon specifications, time and accuracy. If the particle mass is used for accuracy, sample needs to be oven dried overnight before the mass is determined. Particle count states for minimum 200 particles for each size fraction. Uh, American standard specifies minimum lab test sample in dried after reduction from field sample. Depending upon maximum nominal size is tabulated. Here we have different nominal size and minimum mass of sample. When we have the asphaltic concrete wearing course, then we have to sieve it from the nominal size, which is 19 millimeter, and minimum mass of the sample would be 5 kg. When we have the asphaltic concrete wearing course, which is the same, we have the nominal size 25 millimeter, and the minimum mass of the sample is 10 kg. When we have the asphaltic base course plant mix, then we have the nominal size, which is the passing or opening sieve, or maximum size square opening is 37.5 millimeter, and minimum mass of the sample is 15 to 20 kg. Coming towards the most important part of the test, which is procedure. If determination by mass is required, oven dry the sample to constant mass at a temperature of 110 degree plus minus 5 degree centigrade. If determination is by particle count, drying is not necessary. The given sample is sieved through square opening sieves. The retained particles are weighed, counted and denoted as W1, W2, W3 and onwards. The sample is placed in separate plates. Passing and retained sieve size for each fraction is written on the plates. The sample is then passed by its least dimension through the corresponding opening of flaky sieves. Weight, then count and separate and record as F1, F2, F3 and onwards. Collect all the material passing and retained and mass through the elongation gauge, which we have demonstrated in earlier slides, that which is the elongation gauge. Here we can see this is the elongation gauge and this is the flakiness gauge. Collect all the material passing and retained and passed through the elongation gauge. Retained material on elongation gauge are weighed, counted and recorded as E1, E2 and onwards. Results are reported to nearest 1%. Now we have the observations and calculations. Here is the passing and here is the retained. Here the sizes of sieves. We have 50 mm sieve, which is 2 inches, 37.5 mm sieve, which is 1.5 inch, 25 equal to 1 inch, 19 3/4 inch and 12.5 millimeter. These sieves are collected and the sample is placed on them, and we collect the sample which is passing and which is retained. Then we have the mass or count, which is W1, W2, W3. Then we have the mass or count, which is flaky F1, F2, F3. After passing through those elongation gauge and flakiness gauge, then we have mass or count elongated, which is the count from or the mass or count that comes from the elongation gauge after passing through it. The major part is that first we have to sieve our sample, then we have different retained and passing material, and then we have to check by having or passing these aggregates from elongation gauge or flakiness gauge and write our results in here. Now the main thing is that the flakiness index is determined by the summation of all the flaky or count from all the sieves and divided by the total mass which we have calculated in here, and multiply by 100 we have the answer in percentage. Elongation index can be calculated by the summation of all the mass or count elongated, which we have written in here, divided by the summation of total mass, which we have here, multiply by 100, and it gives the answer in percentage. Discuss your results in the light of the following information. If the flakiness index is less than or equal to 15%, it will be fine, and the sample would have a greater strength. And if the flakiness index is greater than these results, or elongation index is greater than these results, then the sample would be discarded and not used in our construction. Thanks for watching.